Now that we studied a general concept and couple of basic formula that we use for factoring, let's check a couple of other examples. So we're going to try a couple of factoring examples. Right? All right, so example, first one. Let's say we have x squared minus 16. Then we have to factor this. Then we should be able to recognize this as x squared minus 4 squared, because 16 is one of those nice squared number. When you square 4, it becomes 16. Then we can apply the formula. Remember that formula that we have, x squared minus a squared equal x plus a, x minus a. Remember that formula? So we are recognizing this a, in our case 4, so this must be x plus 4, x minus 4, just like that. And that would be our almost final answer. Almost final answer. Well, that's the final answer. Sorry, that's the final answer. All right. I guess the variation from this could be something like this: x to the 4th minus 16. Well, this example is very similar to the previous example. So I guess our aim is to rewrite this as something to the square minus something, in this case, for square form. 16 is 4 square, but what do we need to have here so that we could put that into this format? And you can see that this must be x squared, right? X squared. So this that we can factor as this x squared minus plus 4 x squared minus 4, like this. Now let me try this, try to explain this again. Now this formula means whatever that we have square minus whatever that we have square form can be factored like that. So it doesn't have to be x, it doesn't have to be a. We don't really care what that is. Anything square minus anything square should be factored in this form. Remember in a couple of my previous lecture, we had this extreme example saying if we have star square minus, say, moon square, this is half moon, then this would be factored as star, first one, plus moon and star minus moon, like this, right? Oh, a little bit. Okay. So trying to say is it doesn't have to be x, it doesn't have to be a. Whatever that we have square, whatever that we have square, factored in this form. In our example here, this x to the 4 can be rewritten in this format, because we have exponent over exponent. What do we do with these two? We multiply, right? We multiply. So 2 times 2, which is 4. So this x squared works as our star here. Minus 4 works as our moon. So whatever that we have, which is x squared, plus 4, the second term, and whatever that we have, minus this 4, the second term here again. Well, we would finish our answer here. However, if you take a look at this closely, this can be factored one step further. So I can rewrite this as x squared plus 4. The first part can't really factor anymore, but the second part can be rewritten as this 4 as 2 squared, like that. Now we can apply this formula again for this, right? So this would be factored as x squared plus 4 times this one can be x plus 2 and x minus 2, like this. So that would be our complete final answer. I mean, it doesn't look too natural if you've never seen this one before, but this is in a way like very typical trick. So make it 16 so that once you factor it, you still have this 4 to deal with. Then you have to factor it again. So this is very looks very unnatural, but in fact this is very typical type of example that we have to try. All right, let's try a couple of other example. Let's say if we have x squared plus 10x plus 25. Okay. Now we're going to try to factor this using one of those formula that we checked previously. If I rewrite that formula, it looks like this. X squared plus 2ax plus a squared factored as x plus a squared. Now that's the formula that we are going to use. Well, I guess another question could be, when you see a question like this, how do you know that you're supposed to use this formula? I mean, me as a professor, I know this right away, but you know, many students will say, oh, how do I supposed to know that when I look at something like this, that I have to apply this formula? Well, one of the clue is in here, this number 25. If you have a look at this formula a little bit carefully, this last term right here should be a square. So this last number right here must be a nice square number. Like, remember that 4, like 2 square, or 9, 3 square, or 16, 4 square, and 25, 5 square. Then you can try to rewrite this as x squared. Let me get back to the middle term. This one as 5 square form. Now what you need to check is this middle term right there. This middle term. Can I rewrite this 10x in this form? 2 times what's our a in our case is 5 times x. Well, 2 times 5, 10. So we do have this match, which means we can factor this using this formula because it fits right in. So what should be the answer? Well, answer should be x plus, what's our a? 5 squared, right? That should be our answer. Okay. And of course, it's not that natural to see this right away. We do need to do a lot of practice in order to fully appreciate this formula and this type of question. Right? All right. another one that I also like to check is something like this. X to the cube plus 1. Okay. 1 is interesting number because we can rewrite this 1 as 1 to the cube, like that, because 1 times 1 times 1 is still 1. And we know that this x to the third that we have as a first term, so the formula that I have in mind looks like this. Remember that x to the cube plus a to the cube, this becomes x plus a x squared minus ax plus a squared. Remember that formula that I showed you in our previous video clip? So we can use this formula to this question if we can recognize this 1 as 1 to the third. Same deal. So we have this x squared plus something a to the, x cubed plus 1 to the cube, like this. Well, now that we know our a is 1, all we need to do is just replace a by 1. So our answer should be x plus 1 x minus x squared minus 1 times x is just x plus 1 squared is just 1. Right? Okay. So that's going to be our answer for this type of question.